Hey everyone, welcome to another series on Game5D. In this tutorial, I'm going to teach you how we can set up the Ray interactors for both of our hands and controllers. We're also going to see how the controllers and hand Ray interactors are being set up manually so that you would understand the scripts and the data flowing between them and how they interact with each other to have the Ray interactors working. And we'll also gonna see how the Ray interactors for hand is much more easier to set up through the building blocks. So if you are ready for an in-depth learning on how these components work to make your VR app more interactable, I would recommend to follow till the end of the series. So I'm excited to teach you all. Let's get in. Alright, so before we begin setting up our controller and hands Ray interactions, we need the interaction package from Meta. So I already have it downloaded, but if you don't have, go to the Unity Asset Store, and from the Asset Store search for Meta SDK Interaction, and make sure you are also logged in as well. Once you search for the Interaction SDK, you should see 3 of the packages appearing in the browser, and so one of them would be the OVR samples, one of them would be the Interaction SDK itself, and the other one that we need or we are going to download or install is the OVR integration package. So if I head over to the integration package, you should see from the description says that it allows the Interaction SDK, which was the previous package that I showed you, to interface with the OVR plugin. So this particular package contains the scripts and prefabs that's going to allow the previous Interaction SDK to connect with OVR plugin. So it has a dependency on the Interaction SDK by itself. So it's fine if you don't have the Interaction SDK installed, it will automatically install it, but you have to add it to your package for your package manager to find it in your project. Alright, let's head over to Unity. And inside of Unity, you could see like I already have the OVR integration package downloaded, and what you have to do if you don't have is to head over to Window Package Manager. From here go to My Assets and filter out with the keyword Meta, and once you do, you should see the OVR integration package showing up in here. And just to show you, so this has the dependency on the interaction as well as the core SDK. So once I download this integration package, it's going to auto download the Interaction SDK, and you could see that the Interaction SDK is installed as a dependency for the OVR integration. So once you install the packages, just make sure they are in the packages folder, and then we are good to go. Alright, so once you have the packages installed, now it's time to set up our controllers Ray interactions. So head over to a hierarchy, and in the left controller or right controller, let's open up the hand controller and see or the controller tracking that we added through the building block in the previous video, and see what that contains. So if you remember, the controller tracking left that we added in through building block only contains a script that enables the right model of the controller based on the headset that we are on, and or your VR app is being built on, and on the controller model itself there is only a single animator component that allows you to animate the buttons and sync those button movements in the VR app. But there is nothing that can identify this to be a controller, so there is no controller script on it. And the interaction package itself contains Ray Interactors. Ray Interactors, just search for Ray Interactor and make sure you are not in assets but rather in packages or in all, but always it's a good practice to check in packages first, so that because all will show you in on assets and in packages. And just to show you that it exists in packages, I have selected packages, and you would see that there are 2 types of interactor that Meta provide to us. One is for controller and one is for hand. And if I close the filter out the search field, you should see that this indeed exists inside the Interaction SDK, not in the OVR integration package but rather in the Interaction SDK package. And in the Interaction SDK, it exists inside of prefabs runtime, prefabs and Ray folder. So let's see what the Ray interactor contains and why it cannot work with the existing controller. So the reason the Ray interactor won't work is that, let me just drag and drop in the scene view just to show you. Okay, it indeed contains the ray that we're going to cast out of the controller, and it also contains a cursor at the end of it, so it will be appearing where the ray can point at. But if you look at the scripts that are on the Ray interactor, so the first one, controller ref, requires a type of iController type, and that controller ref now is missing for us because the building block doesn't contain any script identified as type of iController. And the reason the Ray interactor needs these particular reference is because it can use that data to tell the Ray interactor saying, hey, this is the current controller we are referencing to, and you fire the ray or start the ray origin from that particular controller position. So this Ray interactor needs to be part of a controller type, and based on that data then this can act on. So if I leave it and build it on the scene, this will only create a Ray interaction in the world space, but that won't be following our controller. So then how do we do that? Then how do we get the hold of the controller script, because it's not available on the building block? So in order to do that, what we're going to search is something called OVR Controllers. And once you do that, make sure you are in packages as well. So this OVR controller, you can see it's a different prefab variant. It's not a prefab but a variant, and it's inside the OVR integration interaction package, and not in the simple interaction package but rather in the OVR integration package. And what this contains, if I drag and drop onto the scene view, so these indeed contain two separate controller sub transforms or subchild, or you can call it child transforms, and on each of them you would see there's indeed a controller script. And these controller scripts are specially designed or provided from Meta so that we can have each of these interactions separate from the camera rig. And the reason I'm telling you is that if let's select the left controller for now and focus on one of the controller, because that's been replicated for the right controller. So if I open up the script here onto the right, so the current controller script, if you look at it, contains few of these sections. One is for update, one is for data modifier. So the way this works is that this controller script requires something, this controller script will update itself after a data. So this is an optional field, but again, this requires a data, and it will only update itself after this data or this particular component or script has run. And after that particular step, then this controller is going to update itself. And so what this data, if you click on it, it targets to, or basically it selects another child source, and this is the actual data source that's going to give us the controller data from the OVR rig. And the reason this is separate from the OVR rig is because once you start developing Unity applications, you know that it can be cumbersome and it can be very crowded, and it's not a good practice to drag and drop everything in the camera rig, because in that case, let's say if you want to modify or remove some of the component you added earlier, so that can increase the chance of deleting some of the camera rig component, and it can happen very much without you even realizing it, and something will break in the game, and you will just struggle figuring it out like what broke, right? And that's the way we tend to keep the hierarchy organized. And for that reason, Meta has divided it into a data source, and so that we can, for example, let's say if you need the controller data from the OVR rig, we can get it from using this component. The component name is from OVR controller data source. But this data source cannot update itself, so it also requires some sort of data source from the OVR rig, so that it can fetch all those data from that camera rig. And that's what this OVR data source is for. So the OVR data source requires a camera rig reference, not the camera rig itself that is on here, but rather a camera rig reference which can point to this camera rig. and that's what we're going to give to the OVR controller data source. But before you set everything up, so first of all, what I tend to do is that because it has a dependency, close dependency on the camera rig, and we also want to keep it separate. So what we generally used to do is that we create an inside of the camera rig, but outside of the tracking space. Make sure you click on the camera rig and not on the tracking space. I create an empty game object, name it interactions, and this is going to contain all the interactions for controller or hand inside of it. So it's still under the camera rigs, so that if we delete the camera rig, then there is going to be no interactions in the scene, and that's what we want, because the interaction for the controller or the hand is going to depend on the camera rig data itself. And inside of it, just drag and drop the controllers, OVR controllers, or if you want to go more minute in detail, so you can just select like OVR controller ray casting, but for now it's fine. Alright, let's open up the left controller again and click on the data source and to see what type it is requiring. The type of camera rig it requires to read the data from is called OVR camera rig ref. It's an interface, there's an eye prepended to it. So the way we get the data is either you can add it on the interaction, but what I tend to do is I create another empty data, and this will contain all the data scripts that we require from the camera rig. Inside of it, so we need the camera rig ref. So we'll just search for OVR camera rig ref, not the camera rig, but rather the reference of it. And since it already, so once we apply the script, it will automatically find the appropriate camera rig reference that is existing in the scene, and it also check this require OVR hands. So this checkbox enables the filter, once this reference gets the data from the OVR rig, it will also filter out the hands if they exist. So that's why there's an optional check for it, because your app may or may not need hands. Okay, once we have the data, so we'll assign it to the left and right controller data source. So that should give us the camera rig reference. Awesome, we have the camera rig reference, but now there is something else that we also need. So the way this works is that the camera rig contains the tracking space, and all the tracked anchors that are inside of the tracking space are related to the tracking space and not the camera rig itself. So the tracking space can vary in your app, and this is the space that basically gets mapped to your eye level or floor level or stage level that we set up on the camera rig itself. So once you select the floor level, so the tracking space, once your app opens, is positioned at the floor level, at the down level, and each of the tracked anchors are then now moving on relation to the tracking space and not in the wall space. But the data that we require are outside of the tracking space, so we don't have any knowledge about where the tracking space is, and it shouldn't also need to know about that. So then if we get the data directly for the controller and use it, then we may get some weird results. So it may possible that it may not match your hand rotation and position, and it may appear somewhere else in the space. So in order to filter out the data and also to convert into the wall space, we also need something called tracking to wall transformer. So that by the name of itself says that we going to change whatever data we're going to get from the OVR camera rig reference. We're going to change it from the tracking space to the wall space, and that is again another script that is provided by default from Meta. And if you search from the same name, and we'll tag it to the assign it to the camera rig data component. So it's called tracking to wall transformer OVR, and it also requires the camera rig reference, so we'll give that camera rig reference to it, and now it will convert every data, like anything from the camera rig tracking space to our wall space, so that we can use it freely inside any of the dependencies of the data. And now we can drag and drop. Make sure you select both of them. I'm selecting both of them so that I don't have to do it separately. and drag and drop to the eye tracking wall transform. Alright, so once we have the data, make sure you also select the handedness that is correct for the left and right controller. I see this is also set to left, so I'll just change it to the right controller. And we don't have to update this particular data source because now whatever we need is going to be automatically, like the data source is already going to have it, so we don't need to update it. But what we need to update is the right controller and left controller. So the update means that this particular position or the rotation or any of the data in this transform is going to update after this particular step, and this particular step can be of different data source type. But we need to update the left controller and right controller game object to follow the same position that our left and right hand anchor are in the camera rig. And that way then we can have basically a parallel controller, or basically an object following the left hand anchor without having a direct link to it, which is really great, and it creates it's a lot simpler and modular architecture to add on new stuff without having to modify the camera rig, and that's what we want. So once we have the left controller, right control selected, make sure everything is correct. So the controller active state only enables all the so the way it works is that it just checks for all the or what do you call it, like child transforms or child components, make sure they are active, because that's what the controller is going to show to us. And then we have the controller visual. So this controller visual is exactly the same as of these tracking left and tracking right. So if I click on the controller prefab, you would see that it indeed contains the OVR controller helper, and similar to how the building block controller left contains all the models, this also contains all the models to render the right one. So you have to select the appropriate left and L touch, right touch to set it up if you intend to keep this visual and disable the controller visual from the camera rig. But since I already had it set up, I would rather if I disable it, the active controller state is going to enable it again, so it's better you can just delete them from the scene. And now you have the tracking or the controller model been showing up been shown to us from the camera rig, and anything else for the controller ray we're going to add into the left controller and right controller. Okay, so we'll go back to the search in the project view and search for the same Ray interactor, or if you remember, you can just navigate directly to the OVR interaction SDK, click on runtime, then underneath the runtime make sure you hit prefabs, and in the prefabs make sure you select the Ray controller, Ray interactor. And because I've done this a million times, so that's why I remember this, otherwise you can go for the search one. Alright, now let's drag the Ray interactor onto the left controller that follows the OVR rig, left and right controller that follows the OVR rig, and make sure they are zeroed out. But I don't think it's required though, because anyway the positions are going to be overridden by the controller once we apply the data to it. So once you drag and drop it, the thing that you will see is that similar to how the left controller or the camera rig ref got the data or set the script, similar to that it will automatically set the right and left controller reference onto the controller ref. And make sure just double check that this indeed points to the appropriate controller types. And once you do that, so we now have set up the data really correctly, and that's how easy it is just to set up the controller's Ray interactor. And before I build it out, let me just explain you what the Ray interactor does. So the controller ref data is going to get the data for the controller respective controller, but the actual Ray interaction happen in the Ray interactor. So the Ray interactor is a type of pointable interactor. I think I can show it to you guys. Pointer interactor or something called, yeah, pointer interactor. So this is a generic class that can take or abstract class, abstract class taking an interactor and interactable to interact with, and the pointer interactor inherit or implement that abstract class, and it contains few of these settings that are required to require for you to understand, and I just don't want to build it out and show the same stuff again like many of the YouTube videos does, but I need you to understand how the script works. So you have the max iterations per frame. So this sets up like how many times you want the array to fire per frame. That means it's going to show the array 3 times per frame. Then the selector is the one that's going to select or basically send and select event once you point the array at an interactable item. We haven't set up the interactable item yet, but what this does is if I click on it, it will select some again a child object of the interactor, and it has a controller selector object which allows you to set up let's say if you want to select something using the trigger button. By default it takes the trigger button, but you can also change it to any button. Let's say I only want to select through the grip button, then I can disable the trigger button and enable the grip button. That means now on the left controller I can select objects using the grip button. Or if I want, since this is a bit mask, so I can select multiple buttons as well. For example, if I want to have the selection event fire from both the grip button and trigger button, I can do that as well. In fact, you can select all of it, but that's I think unnecessary most of the time. But unless if you have something a good use case of it, make sure you drop that in the comment section for everyone to know when to use everything. But yeah, I'll just leave it onto the trigger button. And another thing that you need to keep aware of, although it's very rarely used, it's called require button uses. So since you can select multiple buttons, you can select when the event is going to be fired. Either you want any of the selected button to be pressed for the selection event to get fired, or do you want all the selection button or the button uses selection button to be pressed simultaneously before you can send an selection event. So if I set all, that means, and select grip button and trigger button, that means I have to press both the grip button and trigger button in order to send an selection event. If I select any one of them, then that won't fire the selection event. So sometimes you may need, sometimes you may not. I think most of the time you may need this when you have the hands being shown up as a controller. But anyway, so I will just set it up to the default values that we had. I think it's for trigger and any. So that's how you select for the array, like whatever the array is pointing at, you select that. Next thing that you will see is the array origin, and the array origin contains a transform from where the array origin is going to start, and you would see that it's pointing indeed to the very 0 position, and it contains a array pointer pose. So it's mentioned as okay, it's going to fire the array from whatever position that this point is currently in, and from here it will fire 0.02 centimeter or 0.02 units forward. You need to fire from some other distance. So this is the script that you need to look at and set it up. And same thing goes for the max array length, like how far the array is going to reach at. So you cannot have an infinite length, you can increase it, although so you can do it like 10-50 centimeter, but sometimes most of the VR are confined within the 10 meter space for the user to interact with. Then the equal distance threshold means, let's say if you have different objects and you can point in her middle of the object, and both of them are interactable. So the ones to the ray that is near to the ray distance or ray where the ray is pointing to, and if that distance between that ray point and the interactable surface is lesser than the threshold, that's the one it's going to select. Alright, so now we have the Ray interactor setup. I hope you understood all these fields. Now let's do a quick build, and I'll show it how it appears in the quest. Alright, as you can see, we got our interactors working with our controllers. I'm pressing the trigger button and the grip button and nothing is happening, but as soon as I press the trigger button, you can see the controller selector indeed is making the ray blues, mentioning that we are selecting something. You can also see the distance between the ray, it's about 2 centimeters away, and that's the pointer pose script. Alright, let's move on. Alright, so let's set up our hand interactors. So similar to what like how we had OVR controllers, we also have another prefab variant from Integration SDK. It's called OVR hands. You can search for it, and if I select the OVR hands and then clear the field, it exists in the same OVR integration interaction SDK runtime prefabs folder. So we'll just drag and drop that onto the interactions game object that we created. So once we do that, you would see it contains two left and right hands, similar to how we had like left and right controller. But one more thing you would also see is that it also added this black or synthetic hands visual to it. So now there are two options for you. Either you can keep these visuals if you are okay with the theme of it, or you can still keep the blue hands that we get from the building blocks we created earlier. And you can have that, and you can just delete these visuals from this OVR OVR hands prefab variant. For this tutorial though, I would like to keep this particular black hands because they do match with the gray theme that I have. So what I'm going to do, and if you are also going to use these hand visuals instead of the default ones that are generated at runtime, so select the building block hand tracking left and right. Don't delete them, but rather just disable the OVR mesh renderer script and skinned mesh renderer script. So disable both of these components to stop auto generating the hands. And the reason we are not deleting it is because we need the OVR hand and OVR skeleton to generate those hand tracking information for us to read in the OVR hand prefab, and to update our left and right hand based on that. Alright, so once we have that, let's see how the left hand, right hand are being set up. Similar to how we had the left hand, there is a controller script on each of those controller objects. We also have something called an hand script, and instead of reading directly from data and updating the hand, it reads something from called an hand filter type. So let's click on that and see or follow up through the script what they are referencing to in order to understand how the hand works. So the hand data left contains two scripts. So this is the hand filter that the controller or the hand script references to, and update itself after the hand filter update its own reference. Then the hand filter again update itself after something called as last known good hand. So this last known good hand is the script that exists on the top. And the reason the last known good hand is required, because if you think about it, the controllers in Meta or in all the controllers that are available, they contains infrared light or like Bluetooth, and that connects to your headset, sending in the spatial data, and that's how the headset knows where your controllers are. In terms of hand tracking, everything is dependent on the cameras that are around your Quest headset, and the cameras then uses those video feed, run it through a machine learning model that exists inside Quest in order to approximate where your hand positions are. So that's the reason it keeps a track of what's the last known good hand is. Based on that, it applies those filter. The last known good hand then now is dependent on the OVR hand data source. And similar to how we had the controller data source, the script is named as OVR hand data source, and it also requires a data or reference to the camera rig and also to a tracking to wall transform. And let's also set the appropriate handedness for each of them. Now let's add in the OVR Ray interactor, the hand Ray interactor. So similar to how we search for Ray interactors for controller, let's search for again Ray interactor in the project view. In packages, the hand Ray interactor is the one that we need. And you could see like how does this appear, which is basically the same one that you see in the Oculus home menu. So it has a knob that gets smaller and narrower as you do your pinch, and the cursor that exists or we use to tap. So let's drag and drop the hand Ray interactor on both left and right hand. So make sure you drop it inside the respective hand type, because these are the transforms that are going to move along with the hands, and if we have the hand Ray interactor outside of them, it's possible that they will only exist in the 000 position in the world and not follow your hands. So it's important you drop it inside the left and right hand controller objects. Alright, so once we have the Ray interactors, Similar to how the controller ref updated itself, the hand ref now updated itself to use the appropriate left. Same goes for the Ray Interactor because it's the same script as we had on the controllers Ray Interactor. You can see the same script. The only difference in here is that the max iterations per frame is now set to 1. Then we have a selector script. Alright, so before I show you the interactions from the hand, as I said, the hand interactions are just basically invisible raycast that happens, unlike the controllers where you can see the line of the raycast for some distance. So we need something to look at, right? We need to have something to interact with so that I can show you that this indeed works. So similar to how we have interactors, Meta has provided us something called an Interactable. It also exists in the same interaction SDK under runtime prefabs and Ray folder. So we'll just drag and drop it onto the hierarchy and make sure this exists outside of camera rig. Let me just disable the gizmos. Easier for us to see. So this exists at 0.000 position. So I'll just move it a little bit forward, at least 1 meter or 1.5 meter in Z axis. You can just directly type it in, and the height would be around 0.8 meters at height. Alright, so the way it works is that it contains something called an interactable script. It's called Ray Interactable. It can only interacted through an Ray interactor and not an grab interactor. So it has this particular component which is a surface. So the surface, if you look at it, it's a type of collider surface script, and if we click on that, it points to this subchild or child of this. And this collider object is nothing but a box collider and the collider surface script. So the collider surface script then uses this box collider to define the area on the particular object which can be interacted with. So you can have multiple set of collision or interactable areas or surfaces on a mesh, and that's the reason Meta has allowed us this flexible approach to define your interactable surfaces. Also, to debug really quick, Meta has given us this visual script, Interactable Debug Visual, which refers to same mesh that we see here. It contains a mesh renderer and an interactable debug visual, and from the properties you would assume that what this does. So by default the normal color would be red. We can make it to white if you want, but for now I'll leave it as it is. Then the hover color, so it will automatically update the hover color when we hover on it and not select, and if we select it will convert it to a green color, and if this is completely disabled, that means going to be. But before it can show anything, it requires this event to be read from. So that's what you would see from this interactable view, and it's currently empty, and it requires the Ray Interactable view to be provided in order to listen to the Ray Interactable events. So let's just drag and drop it, and now this script will listen to any of the events or interactable events when we are when you're going to interact with it. Apart from that, let's say if we don't want to have a visual and you want to do something else, let's say you want to scale it up or do some other animations, or let's say you want to trigger something else, then there is also a handy script that Meta provides to us. It's called Interactable Unity Event Wrapper. Once this is assigned a component, so you would see all this list of events that gets invoked from the interactable. So we have the on hover event, then unhover event, select event, unselect event, and other events as well. But similar to how we have to provide the Ray Interactable view to this interactable debug visual, we also have a field in here as well. So we have to provide the information to know that on which interactable this needs to listen those events from. Alright, so for now, since we already have the debug visual, we don't need the event wrapper. I just remove it. Okay, so there's one more thing I wanted to show you all, that there is another easiest way, or I would say the most easiest way to set up the Ray Interactor without having to dive into all of this manual setup. And we did for controllers because there is no building blocks available for the controllers to be set up with the Ray Interactors. Similar to controllers, we don't have anything interactable Ray interactor for hands as well. So you would be wondering what this pointable item is. So pointable item is similar to what we see here in Ray interactable. So if I drag and drop this, so it added an interaction block for the hand, but if I delete that, the pointable item you would see it also contains an Ray interactable. So this is a variation of building block for the Ray interactable type. And the easiest way to set up an hand with the controllers and also have the same synthetic hand similar to what we have here is to use the building block synthetic hands. The reason I did not show you all the first at the very first is because it's marked as experimental, so sometimes it may or may not crash your editor. It happened to me twice, so hence I'm keeping it for the last part of the video. So let's consider, let's say we disable our OVR hands, and let's drag and drop the synthetic hands into a scene, or let's just add it using this button here. Okay, so few things happened, and let me take you through each of them one by one. So once I added it, you see that it added this left synthetic and right synthetic hand, which contains the visual, which was the visual we had earlier here at hand visuals left and hand visuals right. So it contains an OVR left hand visual. So this is the same thing, it contains OVR right hand visual and OVR left hand visual. But that's not the case I wanted to show you. So the thing is, first of all, it added this building block under the camera rig. And notice what the building block is not inside the tracking space, but rather outside of the tracking space. And if you look at the type of the components that are on the hand tracking or the interaction, it's the same camera rig ref and tracking to world transformer, which we added to our camera rig data. So that means the building block again uses the same architecture, but rather it is made so much easier to just add it to the scene, and all of these things will be automatically added for you. It also added something called an OVR HMD. So similar to how we got our data source for controller, for hand, and the interaction automatically spawns something for the HMD as well. So if I expand HMD, you can see it's also called an HMD data source. In case you need the headset data for some of your task or interaction, you can use this. So it is an additional thing that, although it's not needed for hand tracking, but it's still giving it as part of the interaction game object that it added. And other than that, everything else from here is similar to what we had for the left hand and right hand. If you look at it, it's called hand tracking, and underneath of that we have the left hand. Compare that to the previous left hand, same hand scraped and hand active state, hand scraped and hand active state. Then we have the hand data left, which contains the both filters and the last one good hand, same scripts, and everything else is completely same. And the good thing about the building block is that it automatically sets up the OVR camera rig to take the reference from this interaction components. So in this manual way, we just have to, or we had to manually drag and drop the camera rig data that we created onto both of these points, but it's automatically added for the rig. So technically it's all set up to show you the same synthetic hands, and I can show you in the scene view since this is disabled. If I go back to the scene view, you would see that indeed we have the hand here. Let me just pull it up a little bit, and you can see both the synthetic hands appearing. So if you don't need the controllers and you just need the hand to be interactable with Ray, I mean you want to have some interactions enabled, so you can do one thing. You can just go to building blocks, add the synthetic hands, you get the synthetic hands, and on top of that, now we can add our hand Ray interactors. So again, same way. I mean, this step is manual because there is no, as I said, there is no building block to add an Ray interactors, but rather a synthetic hand. So that's what this added. And on top of that, then we can add our own interactor, similar to how we did with the manual way. Drop it on the left and right hand, or right hand transforms, and it should automatically pick up the correct reference type, and that's it. Alright, now we could see our hands showing up, which is really good. And you can also see that the Ray Interactors for hand indeed is reacting to the pinch strengths. And if I point onto the Ray Interactable surface that we added, it indeed is changing color on hover, and if I'm selecting it, it's changing it to the green. So that means the Interactors and the Interactable both are working on. So I can hover on from both the hands and select the Interactable to see how it reacts. So let's pull up our controllers and see if that is working as well with the Interactable. Alright, I hope you enjoyed this series, although it was in depth and it was a bit long, but it was informational. And if you like this content, please hit like, subscribe to the channel. Alright, see you in the next one.